Hi students, welcome to lesson 5.5 on the domain and range of relations. Okay, so first of all, domain. What is the domain? It was mentioned a little earlier on in the course. The domain is defined as the set of independent variables. Okay, so anything that the independent variable can be, that's your domain. So usually we represent the independent variable with the letter x. So basically what we're saying is all the possible values of x. All right? The range is all the possible values of y, so the dependent variable. Okay, so on an x and y axis, so let's say we have an x-axis here and a y-axis here, all the possible values of x, that's your domain. All the possible values of y, that's your range. Okay, so there's different ways of representing domain and range. We're going to use set notation today. This is something you're used to. So x is part of the real set of numbers. So for example, if a graph can have any single value of x, we represent that with the set of all the real numbers, with x is the element of the real numbers. Okay, so what we're saying here is x can be anything. So it could be negative 1.2, it could be 7, it could be square root of 5. Okay, so all the real numbers are part of this, and that we say x is the element of the real numbers. Okay, now how would we write x is greater or equal to 6? Okay, so there's a few different ways to represent it, but the main idea is we want you to know that x is greater or equal to 6 is what we're looking for. So anything larger or equal to, so notice the equal sign. So you might see these different representations in a book. This is the heart and core of what we want, but here this is different mathematical ways to represent it. All right, and the last one, greater than negative 2 or less than 1. So here we would say x is greater than negative 2 but is less than 1. Okay, so notice they're not equal signs on the signs here because we're not including negative 2 and 1. So larger than negative 2, smaller than 1. Alright, so rules for what brackets to use. When writing in set notation, we're going to use curly brackets if we're just representing a bunch of points. So for example, state the domain and range of the following relation. Notice this is 3 points. So the point 1, 2, the point minus 2, 3, and the point 3, 4. So this is x, 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 and this is y, y, y for those x values. So the domain here, so this is where my curly bracket comes in. The domain is all the possible values of x, and notice the possible values of x are negative 2, 1, and 3. So I'm going to write them in order. So negative 2, 1, and 3. Okay, so all the possible values of y is your range, and the possible values of y are simply 2, 3, and 4. Okay, and so now when this is a set of individual numbers, we use those curly brackets. All right, so state the domain and range of the following relation. Okay, so so this is all your possible x values here, and these are related to your y. We saw a diagram like this earlier on in the lessons. So really, I'm going to start with the ordered pairs just to understand what points we have here. So the first point we have is the point 1, 5. So we're going to have the point 1, 5. Okay, next point we have is the point 3, 6. So we have point 3, 6. And the last point we have is the point 3, 7. So 3, 7. Notice that this is not a function because we have one value of x3 that has different values of y. And remember the relationship to a computer. If you plug in a 3 into your computer, it can't get two different things. So not a function, right? So I'll just circle this and just point out that this is not a function. Okay, now going back to domain and range. Well, when it's given to you in this type of diagram, the domain's pretty easy. It tells you what all the possible values of x here. So the domain is simply 1 and 3. Okay, and then the y, the range, is simply 5, 6, and 7. Oh, that's not a nice bracket here. Let's see if I can do better than that. A little bit better. Alright, here's another example where we've stated basically ordered pairs, so points here. So the point xy, xy, xy. Notice again this is a function because the values of x are not repeating. So the domain would simply be all the possible values of x, and we're going to state them in order, and it's given in order, so that's not too bad. So 1, 2, 3, and the possible values of y are 4, 5, and 6. Okay, and the next one, a little bit different. So notice that we've given you all the possible values before this, and so basically this is saying that the pattern continues in both ways. So we're saying -2, -1, 0, 1, 2, which means all the whole numbers are included. So we're going to go -10, just starting at one point, all the way to -1, to 0, to 1, to 2, all the way to infinity, but including only the whole numbers. So there'd be a couple ways to describe this. The way we describe the whole numbers would be x is the element of I. Okay, so there's a chance that you're using z. Okay, so this is x is the element of z. So it depends really who's talking to you, but in English we can use I as the integers. Z is the international letter. So one or the other, it's not both. Maybe I should clarify that. Okay, and I'll let your teacher pick the one that they want to use. So x is the element of integers, which means all the numbers that aren't decimal numbers. Okay, and so notice that the same thing would happen for the range. So 1, 2, 3, 4, 5, 6, 7, 8. And if you go back the other way, if you continue the pattern, 3, 2, 1, 0, -1, -2, negative, all the way to negative infinity. So you would have, again, same thing, y is the element of integers, or you would have y is the element of integers, again, depending what letter your teacher decides to use. I'll let the teacher clarify which one they want to use for integers. Okay, in the last couple examples, we're going to take a look at graphs specifically. So here, instead of giving you ordered pairs, I'm giving you actual points. So the points, if we look at it, this would be the point -3.5. This would be the point 1.5. And this would be -1, -5. So the domain is all the possible values of x. So the possible values of x are -3, -1, and 1. So -3, -1, and 1. And the range would be all the possible values of y. Y is at 1/2 and at -5. Notice that the y is repeated 1/2, so you only have to state it once. So from -5 and 1/2. Okay? So in this one, we have points from -3, 3, and there's a straight line, so all the points between -2 and 4 are included, and we stop at 4. So the domain simply is all the values between -2 and 4, because for all of those, there is an x value. So we would go from, oops, my bad. We would say x is larger or equal to -2 and smaller or equal to 4. Okay, so now for the y values, so the only y value that exists here is 3. Notice that there are no points here, there are no points here. The only points that exist is at y equals 3. So we're going to simply state y equals to 3. Alright, next one. Make sure this is clear that we have a point here, and this is an arrow at the end, which means this line continues to infinity. Alright, so for the domain, well, the domain, notice that this line continues, which means that there's going to be x values all the way here. So we're going to have x values from 0 all the way to infinity. So we're going to say x is larger or equal to 0. Now for the range, notice that the smallest value for the range is -4, and all the values above that, there will be values for y. So we're going to say y is larger or equal to -4. Clean that number up a little bit. And the last example, okay, so now we're domain, we're talking about the x values. Again, this is a point. All the x values from -1 to infinity will have values, right? There'll be values here. There won't be any values over here. So x has to be, in this case, smaller or equal to -1. And it so happens that y has the exact same range, because here the largest y value is -1, and then all the possible y values underneath exist. So you would say y is smaller or equal to -1. Alright guys, I hope that made sense. That's your lesson on domain and range.